I didn't even realize I had the same
All right. Okay, so we have graphing calculators. And we have our unit circle handy for in a little bit. All right, here we go. So guys, this is the last lesson of this massive, huge unit. Our test is Wednesday. And Monday and Tuesday we'll spend reviewing. I'll go ahead and give you the review today for those of you who want to start looking at it over the weekend. I don't want to scare you, but it's a lot of information. So we need to get a handle on it early. I would not wait till the last minute. Okay, so looking at our notes here. Okay, what are some of the meanings of the word inverse? When I say inverse, what do you think of? Opposite? Reverse? Anything else? Okay, we might even use reciprocal. That's a multiplicative inverse. Okay, so we're going to be talking about inverses of functions today. Consider the relation, which just means set of ordered pairs, which I'm calling A, and consists of the ordered pairs 3, 2, negative 1, 2, 0, 7. Is this a function? I've seen a yes, a no, and an I don't know. Because the y's repeat? Okay. Anybody have any other input? Picture this. If you plotted those ordered pairs, what's that test that we use on a graph? To see if it's vertical line. Okay, so picture those 3 points graphed. Would that pass the vertical line test? Yes. So it actually is a function, but you're kind of onto something, Alex. What is it we're checking for if what repeats? The x's, yes. So we know because no x value repeats. Or if we graphed it, the graph would pass the vertical line test. Okay? All right. So when we use the word inverse in math, we're referring to a relation, set of ordered pairs, in which the domain and range are swapped. And the symbol that we use to represent inverse looks like an exponent of negative 1. And I think notationally this is one of the most confusing things in math. Because sometimes this negative 1 means exponent, sometimes it means inverse. So you have to really be careful to see what it's attached to. So in these two right here, this is an exponent. 3 raised to the negative 1 is the same as 1 over 3. X raised to the negative 1 is the same as 1 over x. So those are your exponent rules from algebra. However, in this next one, negative 1 means inverse. So see how it's attached to f of x, which means function of x. So when that happens, that means inverse and not exponent. And like I said, I think that's one of the most confusing things notationally in math. So this would be read f inverse of x, and this would be read a inverse. So what I'm talking about a inverse is we're going to write out the inverse of this set. Okay, it just had 3 ordered pairs. So if I change the domain and the range, what would this set now contain? It would have the ordered pair 2, 3. It would have the ordered pair 2, negative 1. And the ordered pair 7, 0. So I'm just literally going in and changing domain and range around. Okay? Now, not every set of ordered pairs, in fact, we rarely deal with something that is just 3 ordered pairs, right? Okay, oh, and I forgot one thing. What if I plotted this, would it pass the vertical line test? Wouldn't.
Oh, 2.
Alex is opposite day today.
Yeah, apparently so.
So I have 2 2's that are x's. So think about if you plotted those 2 ordered pairs, they would line up vertically. So it wouldn't pass the vertical line test. The x's do repeat. So this would not be a function. So sometimes a function's inverse leads to another function. Sometimes it doesn't. Okay, so rarely do we ever deal with something that is like 3 ordered pairs, right? We deal with equations more often. So take a little field trip back to Algebra 2. When you found an inverse of a function, do you remember what you did? I'm going to rewrite this first as y equals 3x plus 4. How many ordered pairs would make this true? How many ordered pairs could I come up with that would fit y equals 3x plus 4? Infinite. If I graphed it, it would be a what? Line. Y-intercept of 4, slope of 3. So there are infinite points that would make this true. So I can't possibly list all the ordered pairs and then switch them. So when we don't have that as an option, what we do is we literally switch x and y. Do you remember doing that in Algebra 2? So wherever there was an x, it now becomes a y. Wherever there's a y, it becomes an x. So you're literally switching domain and range. And then I'm going to solve it for y, which would involve subtracting 4 and then dividing everything by 3. Okay, so I could say y equals x minus 4 over 3. Or how else could I write that? X over 3 minus 4 over 3, and give me one other way. Okay. Okay, so either way, now this is a little bit easier to tell me. What would it be if I graphed it? What would this be if I graphed it? What would it look like? I'm sorry. A line. Okay, sorry, I phrased my question strangely. Yeah, so this would just be a line that would be the inverse of the original line. Okay, so I can write this either way. It doesn't really matter which way I go with, but we just need to know that they're the same. Would that line be a function? Yeah. Would that line be a function? Yes. So both of these would be functions. How do I know any line is a function except what kind? A vertical. Any other line is a function. Vertical line test would pass. They're inverses of each other. So normally what we'll do in the end, I may have it on the next page, but I would say f inverse equals x minus 4 over 3. Or I could write it the other way, splitting it up into 2 fractions. But instead of leaving at y equals, we'd probably say f inverse equals whatever we found. Okay? All right, next page. Okay, so here is the equation we started with. Here is the inverse equation, bless you, that we just found. So I provided some x coordinates, so let's plug these in and find some y coordinates. We are going to find 3 particular ordered pairs on this line. Okay, if I sub in 1 for x, what is y? 7. If I sub in 0 for x, what is y? And if I sub in negative 1 for x, what is y? 1. Okay, so that represents the ordered pairs 1, 7, 0, 4, and negative 1, 1. Okay, over here on the right, this is the inverse. I want you to sub in 7. 7 minus 4 over 3, 1. Sub in 4. 4 minus 4 over 3, 0 over 3 is 0. 1 minus 4 over 3, negative 1. So that represents the ordered pair 7, 1, 4, 0, and 1, negative 1. What do you notice? Yeah, so these correspond with each other, the original point on the function, and then its corresponding point on the inverse. And so you can see that that's another way that visually domain and range are switched. Okay? And we could pick any ordered pair on the function, and that would work with its corresponding point on the inverse. Now, if we graph a function and its inverse on a graphing calculator, you can either graph along with me or just watch this one. We should be able to see that they are symmetric across the line y equals x. Let's take a look at this. 3x plus 4, and this is true with any inverse, x minus 4 over 3. Okay, so those are my two lines. We knew they would be lines. And the line y equals x is that line that cuts straight through the middle of quadrants 1 and 3. Y-intercept of 0, slope of 1. In fact, I can even graph it. Y equals x. So watch this. And having that graph, you can actually see then, if we were to fold the graph on that diagonal line, this blue matches up with the red. This blue down here matches up with the red. So there's your symmetry across the line y equals x. So any function and its inverse should do that. Okay? All right. Enough of Algebra 2. Now let's move on to, we're going to graph the function of sine inverse and see what this thing ends up looking like. Okay, I have given you on the left the ordered pairs that we plotted when we were first graphing sine. So sine graph is right here. So this is how we plotted the points. Remember, we came up with these ordered pairs at the top here, and I've just listed them here. Okay, so in order to see what this inverse graph looks like, we're going to take these ordered pairs and flip them over here. So we're going to make range become domain, domain becomes range. So the first ordered pair, oh, surprise, is still 0, 0. But the next one becomes 0.5, 30. So I'm just switching domain and range. So let's finish out the table there. Okay. All right, so what we're going to do with this space in the middle is just graph these points. So let's figure out our scale and how we need to set up the x and the y axis. Look at your x values. What's the smallest and the largest? -1 is the smallest, and +1 is the biggest. So on my x-axis, I only need to go out to -1 and +1. Okay, doesn't that already make sense? Because when we graphed sine, the y values went between -1 and +1. But this is the inverse. So now the domain should only go from -1 to +1. So it makes sense so far. Okay, look at my y values. Oh my goodness, I have to go up to 360. I'm not using that kind of scale, am I? Okay, so I've got to go all the way up to 360. Let's just make that 360 at the top, or I'll put 2 pi over there. Got radians and degrees marked. And let's go halfway and call that 180. A pi over 2. And then halfway there is 90 and 270. And then we'll go ahead and extend it to the bottom. Once we see what's going on with this graph, we'll just take it on down to this bottom half. So halfway, halfway, halfway. Okay, so what we're going to do next is just plot these ordered pairs that we have in the table, and let's see what they look like. 0, 0, 0.5, 30. Okay, so I'm going over to 0.5. I'm just going to approximate where 30 is. 0.9, approximate where 60 is. And then 1 goes up to 90. 0.9 goes to 120. 0.5 goes to 150. 0 goes up to 180. Kind of weird, isn't it? Negative 0.5 goes up to 210. Negative 0.9, 240. Negative 1, 270. And then so if we connect them, what's it going to look like? Yeah, it's a sinusoid, isn't it? But it's vertical. Kind of a series of S's here. Instead of horizontal, it's going vertical. But again, remember this is the inverse, so that actually makes sense. We switched domain and range. So instead of my graph going left and right with these waves, now that becomes the range and it's going up and down with the waves. And then let's just continue this on down here. Something like that. Just continue the pattern. All right, is this lovely graph of sine inverse a function? Vertical line test is blown up all over the place, right? I mean, like wherever you draw a line, you're going to have multiple points overlapping. So it's definitely not a function. And what I want to do next is take your graphing calculator and let's graph sine inverse and see what the calculator gives us. Okay, so how do I get sine inverse? Do you see it on your screen? See it above sine? That's sine inverse. So I'm going to go second sine of x. So that means not a -1 exponent, but it means the inverse of sine function. And we graph it. Oh, I'm in degree mode, and you might be also. Go to mode and make sure you're in radian. What the heck? Is that what y'all got? Is the calculator wrong? It is not. Let me show you what's going on. This is part of what we just graphed. Like that. Yes. So it basically, like we define it in math so that it is a function. We just use this one little piece of the graph. Because clearly the whole sine inverse graph is not a function. So what we do is we take out just that little chunk and call that, it's a principal trig function. It's just like this is our function that is sine inverse. It's going to pass the vertical line test. And so that's why that is all your calculator will recognize. So we're going to flip the page over here and we're going to graph just that little portion. So looking back at this page, what I'm graphing here is this little piece from here to here. That's what your calculator is showing you. That little chunk of the graph is what was on our screen. So if I'm going to sketch it here, I only need to go up to 90 or pi over 2 and down to -90 or negative pi over 2, and then out to 1 and -1. Okay, and then the graph itself starts at this corner and goes down to this corner. It's kind of like this is a curve similar to a parabola that's upward, and this is similar to a curve of a parabola that's downward. So that's what we saw on our calculator. And this, sometimes they will use a capital S to indicate like this is the function sine inverse. No overlap vertically, vertical line test passes. So that is our sine inverse. Okay. Looking at just this graph right here, what is the domain? What does x go from and to? -1 to 1. And I do have points at those, so I'll use a square bracket. Remember with this interval notation, you always start with the small number, comma, the big number. Quadrants, I'm going to come back to that in a second. What's the range in terms of degrees? I go to a low of -90 and to a high of +90. So -90 to 90. If I want the range in radians, then we're talking about -π/2 to π/2. Okay, so let's go back to that quadrant question. Let me find my unit circle. Okay, if I am talking about from -90 to +90, here's my unit circle. +90 is this, so it's in the first quadrant. -90 means clockwise 90, so that's in this quadrant, the fourth. So if I'm limiting my range to -90, +90, or -π/2, π/2, I'm really only dealing with quadrants 1 and 4. 2 and 3 I'm totally ignoring. Say that again? Nothing in it? Not of this graph, but of this range. Of this range right here. If I'm going from -90 to 90 on my unit circle, because we're going to use the unit circle in a minute to find answers to problems, then I'm just looking at these two. +90, -90, clockwise, counterclockwise. Okay, so here's just sort of a little demonstration of how the domain and range are switching. This is sine of 30 degrees is 1/2. Okay, if I'm using my unit circle to find sine values, remember sine is your y, cosine is your x. If I go to 30 degrees, sine is 1/2. Okay, but over here, this is read sine inverse of 1/2 equals 30 degrees. Okay, so those are inverse statements of each other. Notice the domain is in a different location, and the range is in a different location because they are inverses. They've switched. Okay, whenever I read a problem like this, I think to myself, there's an angle whose sine is 1/2, and you want to find the angle. So it's kind of like you're going on a little treasure hunt, and you're looking for an angle who has a sine of 1/2. And then that's when this range is going to come in handy, so that we all only get one answer, and we get the same answer. We would only look in these two quadrants for that angle. So there's an angle whose sine is 1/2. I'm looking at y coordinates because that's where I find sine values. I see a sine of 1/2. It matches up with 30 degrees. So that's what my answer would be. So think of this as there's an angle whose sine is this number, and you're looking for that angle. Okay, and just generically it would be sine of x equals y, but sine inverse of y equals x. Okay, to make things even more confusing, there is another way of writing sine inverse, and that is arc sine. If you see arc sine and sine inverse, it means the same thing. They are interchangeable. The calculator just has the sine inverse symbols and not arc sine. Okay? It means the same thing. So if I had sine inverse 1/2 or arc sine 1/2, means the same thing. There is an angle whose sine is 1/2, and we're going to find that angle. It happens to be 30 degrees. Okay, so this is how we're going to use these. Look at these problems at the bottom and get your unit circle. Okay, principal trig values are these that are using just these two quadrants. so that we're looking at a function, so that we're all getting the same answer, and just one answer. Here we go. There is an angle whose sine is square root of 3 over 2. Okay, I am only looking in these two quadrants. If it is a positive number, which quadrant is it going to come from? 1 or 4? 1. Everything's positive in quadrant 1. So we're looking in quadrant 1. Do you see an angle whose sine is square root of 3 over 2? 60 degrees. So that's what that statement means. There's an angle whose sine is square root of 3 over 2. The angle is 60 degrees.
Will there be one that isn't on the circle?
Oh, yes, there will. Hold that question. I'm going to answer that in just a second. Okay, the next one. Arc sine. Oh, that means the same thing as sine inverse. So there's an angle whose sine is negative square root of 3 over 2. I am only looking in quadrants 1 and 4. But if that's a negative number, which quadrant is it going to come from? The fourth. All right, so look in the fourth quadrant. Do you see an angle whose sine is negative square root of 3 over 2? What is it? 300, but that's not what I'm going to call it. Because if I rotate 300, I have to go outside of these two quadrants. I have to rotate through second and third quadrant, and I'm not going to do that because my range only goes from negative 90 to positive 90. So how else can I name this if I get there directly? Negative 60. So instead of calling it 300, I'm going to say I'm going to take the shortest route there, which is to go clockwise 60. So I will call that negative 60 degrees.
Wait, so how did you
Okay.
do that?
Okay, so there's an angle whose sine is negative square root of 3 over 2. I'm only looking in these two quadrants. Sine is positive here, so it's not going to be there. I look down here. I find a y value, which is sine, negative square root of 3 over 2. So normally I'd say, oh yeah, that's 300 degrees. But 300 goes outside of this. So what I'm going to do is just rotate clockwise there. So if between 300 and 360, how many degrees is that? So it's just clockwise 60. Okay. Any other questions on that? All right, moving on to this one. There is an angle whose sine is negative 1. Okay, look at quadrants 1 and 4. Where do you find an angle whose sine is negative 1? Yes, it's 270, but we're going to rename it, and we're going to call it clockwise 90, so negative 90 degrees to get me down here. Is everybody okay with that? All right, there's an angle whose sine is 2. Jerry, look on your unit circle and find me an angle whose sine is 2.
I don't know.
Can I help him? There's not one. Trick question. Okay, how would I know that anyway? What's the highest sine value of anything? 1. Nothing goes above 1. So is there an angle that has a sine of 2? No. So I would just say does not exist. Never going to find one that has a sine of 2 because 1 is the highest sine value. Okay, let's look at E. Arc sine, or sine inverse, of sine 60. Okay, so when we see parentheses, we usually start with those, right? So look at your unit circle. What is the sine of 60? I'm totally ignoring arc sine for now. What can I replace sine 60 with? Square root of 3 over 2. Okay, so this becomes arc sine square root of 3 over 2. This is not arc sine or sine inverse in here. This just says, what's the sine of 60? Replaced it with that. Now, there's an angle whose sine is square root of 3 over 2. Where do you find an angle whose sine is square root of 3 over 2? 60 degrees. Okay, I was so hoping someone would ask me that, because normally you think, okay, those are inverses, they canceled each other out, like squaring a square root, right? But not always the case, like the next one. And then I'll explain why this one didn't work that way. Okay, ignore sine inverse. That just says, what is the sine of 5 pi over 6? Okay, we'll go to 5 pi over 6. That's over there in the second quadrant. And identify sine, which is 1/2. So I'm going to replace this with 1/2. Now my problem is, there's an angle whose sine is 1/2. Find the angle. Well, when I go to answer this question, now it's sine inverse, so I'm limited to just first and fourth quadrants. Find an angle whose sine is 1/2. Well, that happens here. So this answer is actually 30 and not 5 pi over 6. So this one didn't cancel out because 5 pi over 6 wasn't in the first and fourth quadrants. When you're doing the arc or inverse, yes. Now this wasn't in the first or fourth because that's not inverse. That's just what is the sine of 5 pi over 6. Then when I dealt with the inverse portion of the question, then I went to quadrants 1 and 4. Okay, any questions so far? Because of this limited range, so that we're dealing with a function and not this, where I would have multiple answers, infinite answers technically. So that we limit it to just one answer, we use this limited range. Any other questions? I think this is a hard unit, or lesson. Okay, so let's move on. So, next we're just going to explore cosine, because if sine inverse looks like this, y'all, what does cosine inverse look like? Opposite how? So sideways again? No. Okay, so it's still up and down, isn't it? But it's probably going to be shifted a little bit. Yes, y'all are exactly right. Because sine and cosine look the same, but they're shifted versions. So cosine inverse is going to look really just like this, but in different locations, slightly. So let's just go to our calculator and see what this little booger looks like. Let's find cosine inverse of x. So we should expect some little blip of a graph again. Oh, there it is. Okay, so let me show you what the original would have looked like. It would have done this and this. Oops, can you kind of see that? So that would have been the entire cosine inverse graph. But clearly that's not a function. Vertical line test doesn't work. I've got overlap all over the place. So what we do is we take out this little chunk of graph and use it. It's just a different chunk on this one because the graph is in a different place. I can't use positive 90 to negative 90 because that's not a function. So it slides up between 0 and 180. So let me give you a little kind of close-up graph here of what we're looking at. We are still just going negative 1 to 1, but we're going 0 to 180 or pi. Right there in the middle is where it's going to cross over. So we've got this number up here and this number down here on the axis, and we're going to connect them like that. That's kind of like a blown up version. It's like I put this graph under a microscope, and that's what we're looking at on the calculator. So again, it's just one little piece of this continually climbing curve. All right, looking at this, what is the domain? Negative 1 to 1. All right, let's go ahead and answer the quadrant question. Well, let's do the range first. Range in degrees goes from 0 to 180. But if we're dealing with radians, then that would just be 0 to pi. Okay, so now let's revisit the quadrant question. If I am looking at my unit circle from 0 to 180, what two quadrants does that involve? 1 and 2. So this is quadrants 1 and 2. Why can we not use 1 and 4 with cosine? Because cosine's positive here and cosine's positive here. It's not negative in either one of them. So in order to get some negative answers available, we swing over here to the second quadrant. Okay. All right, let's go ahead and look at tangent graph 2. Tangent inverse rather. What did tangent look like yesterday? The repeated cubic curves, remember? Okay, so what's going to happen if we switch domain and range on that? Any guesses?
It'll be like going like this way.
All right. Oh, okay, so let's look. And she's exactly right. So technically, it would be repeated ones of these above and below that, but those wouldn't be a function. So we just use this 1 to represent a function. So, remember on the tangent graph, we had those repeated asymptotes? Okay, they were at negative pi over 2 and pi over 2. They're still here, but they're not vertical asymptotes. They are horizontal because it's the inverse. So we have these dotted, I'll show you when I graph it. We have these little horizontal asymptotes that kind of sandwich the curve. Okay, so pi over 2, or 90, and negative pi over 2, negative 90. I have these lovely little horizontal asymptotes that originally were vertical asymptotes. But when I switch x and y, what was vertical becomes horizontal and vice versa. And then within those, I'll place my little curve. So it's actually like a cube root curve now instead of a cubic curve. Okay, so we just took that 1 that was around the origin, found the inverse of it, which essentially turns it on its side, and we use that to represent our function. What's the domain on this one? All real numbers. So negative infinity to positive infinity. We'll come back to quadrants. What's the range? But do I include them? No, because there are asymptotes there. So we'll just do parentheses, negative 90 to 90. And then if we're referring to radians, that would be negative pi over 2 to pi over 2. Okay, so if I'm back to 90 to negative 90, which two quadrants does that involve? 1 and 4 again. Okay, so down here at the bottom, this is sort of a general or a summary of what we just talked about. If we are looking at cosine inverse or arc cosine, we are searching in those two quadrants. If we are looking for sine inverse or tangent inverse or arc sine arc tangent, we are using these two quadrants. That's what I was about to tell you next. Yes, I will get that formula sheet and put these on it, and I've put them up here on the board right here. So I put something like that, or what you see at the bottom of your notes there, put that on your formula sheet somewhere. And then we'll do a few more practice problems with it. Ooh, y'all are going to have a lot of time left over. Add it to your formula sheet. I'm going to pause this, y'all. Let me forget to start it back up. Okay, so have that unit circle handy. we're going to use the unit circle, not a calculator, to find these. And on this one, just for the fun of it, we're going to express answers in radians instead of degrees. Okay, so use principal trig values. That tells me that I'm using those limited quadrants to find answers. So here we go. There is an angle whose cosine is square root of 2 over 2. Now, because it's cosine, I am only looking in quadrants 1 and 2. So search quadrants 1 and 2 for an angle whose cosine is square root of 2 over 2. Do you find one? And what would that be in radians? Pi over 4. So everybody see where I got that? Okay. Next one, arc cosine. So that means, is there a question or are we? We're good? Okay. All right, so arc means the same thing as inverse. So this means there's an angle whose cosine is -1. It's cosine. We are only searching quadrants 1 and 2 for an angle whose cosine is -1. Remember, cosine is your x-coordinate. So find that angle for me. 180 or pi. So depending on what I want that answer in, if I want it in radians, we'll use pi. Degrees 180. If I don't care, then it's your call. Okay, the next one, tangent inverse square root of 3. There's an angle whose tangent is square root of 3. Tangent is like sine, and we're using quadrants 1 and 4. If this is a positive, which quadrant will it be in? 1. Everything's positive up here. Okay, so, this one's a little tricky. What? It'll be 30 or which other one? Okay. Or possibly, which other one? Could be 60. It's not 45, is it? Because tangent of 45 is going to be 1. So I would definitely narrow it down to these two. How could I decide between the two? How do we find tangent? Y over x. Okay, so is this over this, or this over this, what I'm looking for? Which one would give me square root of 3? The second one. And if you're totally unsure, type those in your little yellow calculator. Remember, the graphing calculator will give you decimals. So that's why I'd probably grab that small calculator. So this is the one that's going to work out for me. So my answer would be 60 degrees in degrees or pi over 3 in radians. Everybody okay with that one?
Okay, so on 3, how did you get
Okay, so an angle whose cosine is -1. Remember, cosine is the x-coordinate. Were you looking at y? Yeah. So x-coordinate -1, I find it over here.
So for the one we just did,
Uh-huh.
you did the one that had square root of 3 in it?
Because tangent is y divided by x. Tangent's always the tricky one. Because
Is that why we didn't do 45? We did absolutely.
Yeah, because I know if I divide that by that, I'm getting 1. A number divided by itself. So I picked the two that had a square root of 3 in it, and I knew it was going to be one of those. So this would actually give me 2 over 2 square root of 3, which is 1 over square root of 3. But this one gives me 2 square root of 3 over 2, which just gives me square root of 3. Okay, but, you know, if you're not sure, check your calculator also. But you know it's one of those because it's got that square root of 3 in it. This one does not, neither does, you know, anything that's on an axis. They're not going to have square root of 3. Okay, any other questions on that one? Okay, arc tangent, which means tangent inverse. There's an angle whose tangent is -1. Tangent is using quadrants 1 and 4. Where can I find an angle with a tangent of -1? Fourth quadrant. It is definitely down here at 315, isn't it? but I'm not going to call it 315. Remember, I'm going to go directly there. I'm going to take the shortest route. So how many degrees is that? Negative 45. What if I want it in radians, though? Negative pi over 4. Question. All right, so now, Lily, this goes back to your question. You said, what if it's not on the unit circle? Not everything we're going to be interested in is on the unit circle. So these down here are examples, and they're super easy because we just totally rely on the calculator. But you have to know what we want the answer in. So for A and B, I want the answers in radians. So we're going to have to put our calculator in radian mode. For C and D, I want the answers in degrees. So we'll have to remember to switch our mode to degree. Just because I told you what the answer needed to be in. Yes. Yeah, I'll have to indicate what I want answers in because you have no idea just by looking at this if I'm in radian or degrees. Okay, so sine inverse. We're going to pull up sine inverse and type in that lovely number. And the calculator will match it up for us, and that's it. So when it's not on the unit circle, it becomes a really easy problem. It's just a calculator problem. Okay, next one. It's got a lot of stuff, but you know what? I can just type it in just like it looks. Cosine inverse. Sine 3.49 pi. And did y'all get 3.11? Okay. Okay, so the last two I want degrees, so go to mode, switch to degrees. It did the same thing. Arctan. Ooh, where do I find arctan? Tangent inverse of negative 4.8. And that gives me negative 78.2 degrees. And then the last one, cosine inverse of pi. Uh-oh. What happened? How much is the number pi? 3.14. So I'm saying, hey, there's an angle whose cosine is 3.14. Cosine doesn't ever go above 1. So that's why this one does not exist. I could find the cosine of pi, but not an angle whose cosine is pi. Okay, save the easiest for last. This you probably did in geometry. And it's using sine, cosine, or tangent inverse to find an angle in a triangle. Okay, so looking at part A, where the question mark is, we'll just call that theta. That's the angle I want to find. But this side 4 is opposite, adjacent, or hypotenuse to theta. Opposite. And this side of 6 is what? Hypotenuse. It throws us when that right angle's up at the top. Okay, so if I'm looking for theta, and I know opposite and hypotenuse, which trig function does that use? Sine. So I'm going to say sine inverse. There's an angle whose sine is 4 over 6. And if I type that in my calculator, it will tell me what the angle is that matches that. If I don't tell you, ask, but I said put it in degrees. Okay? Generally, when we're dealing with triangles, we are in degree mode. But on a test, if you're uncertain, please ask me. So 41.8 degrees. Do you remember doing that in geometry? Maybe. Okay, so looking at theta, where the question mark is, side 22 is the what side? Opposite. Side 24 is what? And what uses those? Tangent. So I'm going to say tangent inverse. There is an angle whose tangent is 22 over 24. And I'll let the calculator tell me what that angle is. What'd y'all get? 42.5. All right. Looking. Oh, sure. Yep. All right. Looking at C, what is side 21? Adjacent. What is side 22? Hypotenuse. What uses those two? Cosine. So I'm going to say cosine inverse. There is an angle whose cosine is 21 over 22. And let's see what matches up with that. What did you get? I heard it from somewhere. 17.3. Okay, you do the last one. If I'm giving you all three sides, what do you use? Whichever one you want. You can do all three if you want, but you should be getting the same answer. Just pick one. We should all get the same answer regardless of which one we use. Those are all three of them set up. And what angle did you get? 53.1? Everybody agrees? I'm just curious, how many of you used sine inverse? How many used cosine inverse? How many used tangent inverse? Good mix of all. Okay. All right, any questions? Okay, so I'll come around with your homework. You guys do have a lot of time. You have 25 minutes. I'll come around with your homework. I will also give you a review for the test today, unless you don't want it until Monday. So you can be working on either of those or finishing up that Delta Math now that you know what inverse means.